Welcome to the second video and the second page of the summer assignment. And we're going to start off with looking at number 10 and 11. And in these two, we want to state using interval notation when the function is increasing, decreasing, or constant. So let's take a look at number 10. Well, number 10, we notice that it is changing right down here at this point at -2, -2. All right, and what do I mean by changing? Well, if we look to the left of that point, this function is going down and to the right. All right, it's in a downward direction. So as the x values get bigger, the y values get smaller. So we say the function is decreasing. So on the interval, now this would be the open interval from -infinity. And it's open because we can't really include infinity. It goes off forever. Up into the point -2, or at least the value of -2 in our domain, we say that it is decreasing. Now, why do we have an open interval here? Well, one, we can't include infinity. And the -2, we don't want to include it because at -2, at that actual point, it's neither increasing nor decreasing. We're going to talk about what it is at that point when we get further into the course. But for right now, let's just keep it an open interval from -infinity to -2. It's decreasing. So if we look at the rest of it, from -2 up into positive infinity, our y values are increasing. So we say that from -2 to positive infinity, this function is increasing. All right? So try number 11 on your own. One thing I do want to mention about number 11, there's a little issue right here. That point, that open circle, should be shifted over to an x value of 5. When it converted to PDF, something happened, and I'm not sure what. It just squished it together. So that open dot, move that from 4 over to 5, and then continue that black arm there. Let's take a look at the next section here where we need to sketch transformations. So we're given a function right here, and in this we're just given a set of 4 points. All right, the points in -5, 1, -3, 2, -1, 2, and 1, 4. And if that is our function f of x, we want to plot the transformations of -f of x to f of the quantity x plus 3 and f of x minus 1 plus 2. So in order to do this, we need to understand how do these things, doing these things to f, affect the graph of the function. So in number 12, we have a negative outside of the function. Now we have to remember, is the negative inside or outside? Here it's outside. So what does that do? Well, that flips vertically. So it changes the y values that were once positive to negative. It does nothing to the x values. It just changes all of the y values to negative. So at an x value of -5, we were at 1. Now we're going to be at -1. And at -3, we were at 2, but now we're going to be at -2. And then at -1, also at -2. And then at 1, instead of up at 4, we're going to be down at -4. So if we look at what happened here, we just flipped the function about the axis, the x-axis here, and we have the mirror image below. All right, now if that negative were inside, we would also flip it, but we would get the reflection about the y-axis. So all the x's that were positive become negative, all the x's that were negative become positive. Okay, so you're going to try 13 and 14 on your own. Keep in mind when you multiply outside, what does that do? You know, it might either stretch it or compress it. When you add inside, remember it's counterintuitive inside the function. When you add, you move to the left. When you subtract, you move to the right. And when you add outside, that shifts up. Okay, so give those ones a shot.